In order to take the derivative of a function using the power rule, it's pretty straightforward. All you have to do is take the exponent, the third on our 4x cubed, and multiply it by the coefficient of 4, giving you 12, and then subtract 1 from your exponent to give you 12x to the second power. Then you'll take the 2 from your 2x squared and multiply it by the 2 of the coefficient out in front, giving you minus 4x to the 2 minus 1, or to the first power. Then we'll take the 8x. 8x is 8x to the first power, so when you multiply, you still end up with an 8 out in front. And when you drop down, you get x to the 0 power, which is 1. So the derivative of the 8x portion is just 8. And then we know that the derivative of a constant, negative 1, is 0. So we end up with f prime of x equals 12x squared minus 4x plus 8. Here's another pretty straightforward one. We'll take the 2x to the fifth, take the power of 5, multiply it by the coefficient of 2 to get 10, x to the 5 minus 1, or 4, minus 3 times 3, 9, x to the 3 minus 1, and then plus x. That derivative of x to the first is 1x to the 0 power, which is just 1. Now, the power rule also works for fractional exponents, and it's the exact same process. So f prime of x should equal 4 times 3 halves, which is 12 halves, or 6. X to the 3 halves minus 1 is 1 half power, minus 2x, so the 2x becomes 2, just a minus 2, because it becomes minus 2x to the 0 power. And then your plus 8x to the 1 half, 8 times 1 half is 4, x to the negative 1 half power, and the minus 7 is a constant, and the derivative of a constant is 0, so this is our derivative. It's possible that we might want to simplify this, so we could write it as 6 root x minus 2 plus 4 over root x, for the x to the negative 1 half. And then if we get a common denominator of root x for all of these, we'll multiply the 6 root x by root x over root x. So 6 root x over 6 root x times root x over root x, minus 2 root x over root x, plus still 4 over root x, giving you root x times root x, which is just x, so 6x minus 2 root x plus 4 all over root x. And we'll do one more. The power rule can also be applied to negative exponents in exactly the same way. So our derivative, f prime of x, should be negative 3 times 2, which is negative 6, x to the negative 3 minus 1, negative 4 power. And then negative 5 times negative 2/3 is positive 10/3 x, and negative 2/3 minus 1 is negative 5/3. 8 times 5/4 is 40 over 4, or 10, so plus 10, x to the 5/4 minus 1 is 1/4, and the derivative of x to the first power is just 1x to the 0 again, so just plus 1. Again, we could drop these negative exponents to the denominator and get a common denominator, but this is also an acceptable answer.